everybody, how are you? You are doing very well. Today, inshallah, our lesson will be as a review for the previous 3 lessons in chapter 12. So, guys, you will try to answer some of the most important questions in your study guide. So, let us start with section number 1. Section number 1, we have discussed about the fossil record, and we said fossils can form in several ways. We have the trace fossils, we have the permineralized fossil, we have also natural casts, amber preserved fossils, and so on. So let's start with our first question here. Use the words in the box to fill in the blanks in the chart below. We have the type of fossil and here the description of fossil formation. So for number 1, guys, organism trapped in tree resin that hardens after being buried. What type of fossil will be result, guys? Remember, yes, he will have the amber preserved fossils. Okay, amber preserved fossils. Okay, so what about question number 2, guys? What is the type of fossil that have the following description? An impression is left in sediment and minerals fill the impression in, recreating the original shape of the organism. Well, it is the natural cast. So number 2, the answer will be natural casts. Okay, so number 3, guys, is trace fossil, and we say that trace fossil will record what? It record, yes, the activity of an organism. So fossils that record the activity of an organism. Examples include nests, burrows, imprints of leaves, and footprints, and so on. Okay, so question number 4, permineralized fossil. The permineralized fossil are fossils that occur when what? When minerals carried by water are deposited around a hard structure, and we say sometimes these minerals may replace the hard structure itself over time. Okay, so the answer here will be when minerals carried by water are deposited around a hard structure. Okay, so what about the last way by which fossil can be formed, guys? Here, organism becomes encased in material such as ice or volcanic ash, or immersed in a bog. Here, the type of fossil is called what? Preserved remains. Exactly, preserved remains. So we have preserved remains, we have the permineralized fossil, we have the trace fossil, we have what else? The natural cast, and we have the amber preserved fossils. These are the 5 main ways by which fossils can form. So guys, let us move to the next slide. Here the question says use the following figure to fill in the sequence diagram that describes the process of permineralization. Remember when we discussed about, I showed you a figure that discussed how the permineralization occur. So we said that first of all, an organism dies and it will be covered, for example, by water. So then sediments quickly cover its body, and then pressure from additional sediment will what? It will compress the body. So pressure from additional sediment compresses the body, and then what we're having, guys, minerals slowly replace all hard structures such as bone, and the fossil may be exposed millions of years after formation, and to be exposed because maybe of earthquake or any other catastrophic event. Okay, so again, guys, an organism dies, then sediments quickly cover its body, pressure from additional sediment compresses the body, and then minerals slowly will replace all the hard structures such as bones, and then fossil may be exposed millions of years after formation. So this is how the process of permineralization will take place. Now let us move to the next idea. The main idea here, radiometric dating provides an accurate estimate of a fossil's age. So we say that we have two ways by which we can have the age of the fossils. We have the absolute or the radiometric dating, and we have the relative dating. So guys, the question here, what is the main purpose of both relative dating and radiometric dating? So what do you think, guys? A, to determine how old the fossil is, or to determine where the fossil falls in the fossil record, or to determine whether the fossil is a missing link. D, to determine Earth's age. What do you think, guys? Exactly, the answer, or the correct answer, will be A. The main purpose of both relative dating and radiometric dating is to determine how old a fossil is. Question number 9. What is the main difference between relative dating and radiometric dating? You may remember that we said radiometric dating will give us the actual age of the fossil, while relative dating will not. Okay, so guys, the answers will be: relative dating compares a fossil with the fossils of other plants and animals that are known to have lived in certain time periods. B, relative dating is based on other items found near the fossil, while radiometric dating is based on the fossil itself. What do you think? Okay, relative dating is based on the other species that are related to a species of a fossil, while radiometric dating is based on the soil nearby. What do you think, guys? Last point, relative dating is based on the half-life of isotopes, while radiometric dating is based on the placement of fossils near other fossils in layers of rock. And of course, for D, it's for sure not the correct answer. So guys, the most correct answer will be A. Relative dating compares a fossil with the fossils of other plants and animals that are known to have lived in certain time periods. So guys, question number 10. What sort of time span can be measured using radiometric dating techniques? A recent time span, such as the last 5 years, or a time span that covers several decades, or a time span of hundreds of years, or a geologic time span such as hundreds of thousands of years? What do you think, guys? Okay. Yes, so the correct answer would be D, a geologic time span such as hundreds of thousands of years. So guys, another question about radiometric dating and relative dating. Match each term with its definition from 11 to 14. 11 measures the actual age of a fossil. What do you think, guys? Exactly, the actual age would be radiometric or the absolute dating. Okay. Next, guys, 12 most elements have several of these. What do you think, guys? Yes, exactly. Most elements have what? Isotopes, and we say isotopes are atoms for the same element with the same number of a proton but different number of neutrons. Okay, so what about number 13? Measure of the release of radiation will be what, guys? What do you think? Yes, the half-life. Half-life is the measure of the release of the radiation of the isotopes, or of the unstable isotopes. Okay, so the question, guys, infers order in which groups of organisms existed, of course, it will be what? It will be the relative dating. Okay. So guys, let us now move to section number 2, the geologic time scale. And here you remember that we discussed about the following terms: the era, the period, and the epoch. So now the question is, fill in the blanks below using the terms in the box. You may use some terms more than others. So guys, for question number 9, the smallest unit of geologic time, what do you think, guys? The smallest unit of the geologic time was, yes, the epoch. Epoch is the smallest unit of geologic time. Number 10, associated with rock system is what, guys? The period. Period associated with what? With rock system. And number 11, consists of 2 or more periods, and of course for 11 it will be era. Era is consists of 2 or more periods. Okay. So next, guys, 12, it will last tens to hundreds of millions of years. Guys, what do you think? Again, the answer will be the era. Era lasts tens to hundreds of millions of years. Okay. So what about, guys, number 13? It will last several million years. What do you think, guys? Exactly, the epoch. Epoch will last several million years. For 14, guys, 14, it will last tens of millions of years. Exactly, it will be what? The answer will be period. Okay, then next, guys, we have 15, most commonly used units of geologic time. Remember, guys, we discussed about this point. For 15, again, it will be period. Period is the most commonly used units of geologic time. Okay, so for number 16, examples include the Paleozoic, the Mesozoic, and the Cenozoic. Guys, for now, exactly, for number 16, the correct answer will be era. Okay, and finally for 17, examples include the Cambrian, Jurassic, and the Quaternary. Exactly, here for 17, the answer will be period. So guys, the following question, I will leave it for you as homework, and now let us move to the next slide and section number 3, origin of life. Number 3, origin of life. The main idea is several sets of hypotheses propose how life began on Earth. So fill in the blanks in the chart. We have here the 3 hypotheses: the organic molecular hypothesis, early cell structure hypothesis, and RNA as early genetic material. So for the first hypothesis, organic molecular hypothesis, we discussed about the Miller-Urey experiment. A Miller-Urey experiment demonstrated that organic compounds could be made by passing electrical current through a closed system that held a mixture of gases. Okay, what about the other, guys, hypothesis, the meteorite hypothesis? It showed that 19 amino acids found in a meteorite that fell near Murchison, Australia in 1969 were found in other places on Earth. But the second hypothesis, guys, the early cell structure hypothesis, we discussed about iron sulfide what iron sulfide bubbles hypothesis exactly, and the lipid membrane hypothesis. So for iron sulfide bubbles hypothesis, simulated in the lab, making a chimney structure with compartments that could have acted as the first cell membranes. What about, guys, the lipid membrane hypothesis? Discovery that lipid molecules spontaneously form membrane enclosed sphere, okay, or spheres. For the last hypothesis, the RNA as a genetic material, RNA world hypothesis. So theory that RNA, not DNA, stored information in living things on early Earth. So guys, for this question it will be homework for you as well. So today you have two homeworks, guys. Please try to answer these questions, and that's all for today. Thank you, and see you inshallah tomorrow.